Hey guys, today I want to talk about something you learned in Algebra 1 and kind of build off of it, and that is something called the zero product property. What it says is that if A times B equals 0, in other words, if two values multiplied together equals 0, the only way that's possible is if either A is 0 or B is 0 or both. Okay, so another way to say that is if a product of factors is 0, product meaning multiplying, factors meaning two or more things multiplied together. If we do that and it equals 0, the only way that's possible is if at least one of those factors is 0. It should be a fairly obvious statement, but where it's really important is how it applies to algebraic concepts. Okay, so let's take, for instance, these two problems, which actually are the same problem asked in different ways. So first I want to point this out. Solutions to an equation just means if you solve this equation, what values of x make that equation true. In this case, this equation set equal to 0. That is equivalent. Asking to find these solutions is the same as me giving you a polynomial that's not set equal to a number and say find the zeros. What we mean by find the zeros is take this equation and literally set it equal to 0 so that it looks exactly like this. Okay? To be comfortable with either one of those instructions. But for our purposes, what I want us to talk about is the fact that we have this equation that has three terms added together. And when things are added together, if it equals 0, we just don't know what two numbers add up to 0 because there's an infinite combination. 10 plus negative 10 equals 0, or 5 plus negative 5 equals 0. We could do that all day. There's an infinite number of combinations. But if I could find a way to make this equation into a multiplication problem where something times something else equals 0. The only way that would be possible is if each of these is equal to 0. And so this is stuff you spent a good deal of time on in Algebra 1, and I want to kind of remind us of that process and then extend it to something further today. Just as a quick refresher, if I was trying to find out a way to multiply two binomials together to equal x squared plus 6x plus 8. This is called factoring. So we know that x times x would give me x squared, and whatever two numbers go in here, they have to add to 8. Excuse me, they have to multiply to be 8, and they have to add to be 6. Okay, and so those would be positive 4 and positive 2. You can test this by trying to multiply it out. X times x would be x squared, 4 times x would be 4x, 2 times x would be 2 more, 4 plus 2 is 6x, and 4 times 2 is 8. So that's we should be somewhat familiar with that. But the big point is, now that this says one thing times another equals 0, we can set each of those equal to 0 because we know either x plus 4 equals 0 or x plus 2 equals 0. That's the only possible way this equation could equal 0. So once I have that written, I can go through the very basic algebra to solve, and I find that the answers to this equation are either negative 4 or negative 2. Those are the only possible solutions to this equation because of the zero product property. Just another example of a question you might have seen in the past and how it could look. I could ask you to solve an equation like this. Notice that it's not equal to 0 right now. So the zero product property wouldn't help us. Well, this is why our first step in a problem like this would be to move everything to the same side by subtracting 3x in this case. And that way I would have an equation that is set equal to 0. And now I can say, well, if I could turn this problem that's a bunch of subtraction into multiplication, then I would be able to set whatever's in these parentheses equal to 0 and solve, and it would be very simple. So again, I'm looking for numbers that multiply to be negative 28 and add to be negative 3. So going through factors of 28, we have like 1 and 28, or 2 and 14, or 4 and 7, and that's going to be what we want. So we will have x minus 7 and x plus 4, because negative 7 plus 4 would add to negative 3 and multiply to be 28. That's kind of old news to a lot of you, but I wanted to make sure I at least kind of refresh ourselves with what's going on. This goes right in hand with what we've been doing with multiplication. Again, we could test this by multiplying and distributing it out, but I don't think I need to do that right now. The point is, again, now this is a multiplication problem, so The zero product property tells us that either x minus 7 equals 0 or x plus 4 equals 0 or both, which means our solutions, if I solve this for x by adding 7 to both sides, would be x equals 7. And over here I could subtract 4 from both sides and get x equals negative 4. So the solutions to this problem are 7 and negative 4. So far, everything we've done is stuff you've done before in Algebra 1. So why am I bringing it up today? Because we can extend it to something more like what we're talking about here. So what if I have a higher order polynomial? So let's take this expression here and say I want to solve it if it's set equal to 0. That should have been there in the first place. Okay. So if I want to solve this equation, notice that if I were to try to FOIL this out, if I distributed x squared times x squared would give me x to the 4th. This is a polynomial with a degree of 4. But since right now it's written as a multiplication problem, as this factor times this factor, then that means I can set these two factors equal to 0 separately. So I could write x squared plus 5x plus 6 equals 0. And I could also write x squared minus 3x minus 4 equals 0. And both of these things, solving these equations separately, is how I would find the solutions to the overall equation, because the zero product property tells me either this is true or both. How do I solve this equation on the right? Again, it's just a bunch of addition. Well, I can apply my factoring to this equation separately and say, okay, x times x would give me x squared. I need two numbers that multiply to be 6 and add to 5. So I'm going to do x plus 3 and x plus 2. And if now that I have a multiplication problem, zero product property applies. I can set x plus 3 equal to 0, and I can set x plus 2 equal to 0 and solve these two things separately. So again, I would subtract 3 from both sides, which gives me x equals negative 3 for this equation, and then subtract 2 from both sides, which would give me x equals negative 2 for that equation. I'm only halfway done, right? I have this other equation set equal to 0 that I have to solve. This is subtraction. I need to turn this into multiplication. So I factor again. I try to turn this into a multiplication problem. So I know x times x is going to give me x squared. I need numbers that multiply to be negative 4. So in order to multiply two numbers and get a negative, that means one has to be a positive and one has to be a negative. And I want them to add up to negative 3. Okay, so that means I need a negative 4 and a positive 1, because negative 4 times 1 is negative 4, and negative 4 plus 1 is negative 3. And once I find those factors, I can set them each equal to 0. And once I have them set equal to 0, I can solve each one. So this would give me x equals negative 1, and this would give me x equals 4. What the heck is the answer to this problem? There's all sorts of stuff all over here. The answer is there are 4 different solutions, right? There are 4 solutions because this has a degree of 2, this has a degree of 2, total that's a degree of 4, so I should have 4 answers, and they are negative 3, negative 2, negative 1, and 4. All of these are solutions to this equation. To look at how multiplicity, or how the zero product property comes into play here, and it's kind of just extending the factoring idea that we've done in Algebra 1. But there's one more kind of new thing I want to talk about, and that's something called multiplicity. Multiplicity is something we use to describe how many times a zero of a polynomial exists for a given function. Or another way to say it is every zero has multiplicity. Okay, and the multiplicity is equal to how many times the factor appears in the polynomial. That may sound like a strange comment, so let's look at an example to kind of show you what I'm talking about. Okay, here I have an equation that has one factor x minus 6 that has an exponent of 12, and another factor x plus 3 that has an exponent of 5. What this would literally mean if I wrote it out is x minus 6 would have to be multiplied together by itself 12 times, right? I would write that out 12 times, the same exact factor. So every time I solve one of these, if I set x minus 6 equal to 0, I'm going to get the same thing every time. I'm going to get x equals 6. So in this case, all of these have the same quote-unquote 0, and it's 6. But how many times would I have that same exact answer? Well, I would have it 12 times. So what we say is that x equals 6 is a 0, and it has a multiplicity of 12. Okay? And then on the flip side, we also have this factor over here. X plus 3 is raised to the 5th power, meaning the same factor is repeated 5 times. So if I were to take that factor and set it equal to 0, just like I had before, I would find out that x equals -3. So that's my 0, but that 0 has a multiplicity equal to how many times it repeats. And how many times does it repeat? 5 times, because that's what the exponent is. Another way to say it is just that the multiplicity is the exponent that's attached to whichever factor you're talking about. Okay, so let's look at another example and make sure we understand this. So here we have tons of different factors. Okay, so let's kind of look at this one at a time. First of all, there's a number out in front. It's a 3. Does that mean 3 is a 0? No, it does not. Okay, remember what zeros are what we get from solving for x. And so if there is no x, there is no 0. Okay, so this has actually nothing to do with what we're trying to do right now. Individually, I would solve each one of these equations if I set them equal to 0. So this one would give me x equals 5. Right? This one would give me x plus 4 equals 0, which would tell me if I subtract 4 from both sides that x equals -4. Okay, I would write x plus 5 equals 0, which subtracting 5 from both sides would tell me x equals -5. And then my last one would be x minus 2 equals 0, and x would equal 2. Okay, so here are my zeros. There are 4 of them, but they each have multiplicities that are more than 1. Well, most of them do, right? The 5 is attached to this exponent of 3, so I would say it has a multiplicity of 3. This -4 has an exponent of 2, so it has a multiplicity of 2. My x plus 5 factor appears 4 different times, so the x equals -5 has a multiplicity of 4. My x minus 2 didn't have an exponent, meaning it doesn't repeat. It's only there 1 time, so my multiplicity here is 1. So it's a pretty basic idea, and that tells us the total number of zeros that this function has. Look at just one more problem. This has a degree of 3. Okay, just in case something like this pops up. If you ever notice that our function doesn't have a constant term, right? Normally we're used to seeing like +3 or -7 or some number at the end. This problem has an x in every single term. So I want to kind of remind us of something called the greatest common factor. Each of these terms has an x in it, which means there's an x that's common that could be factored out. So if I took an x out of x cubed, I would be left with 2 of them. If I took an x out of 4x squared, I would be left with just 4x. And if I took an x out of this, there would only be a 4 left. There would be no x, right? Imagine if you distributed this x times x squared is x cubed, x times 4x is 4x squared, x times 4 is 4x. So once I do that, if I want to find zeros, I want to set it equal to 0. And so then I could try to factor this, right? So x times x I know would give me x squared, so those are in here. I'm looking for 2 numbers that multiply to be 4 and add to be -4, right? There's only a couple numbers that multiply to be 4. That's 1 and 4 and 2 and 2. So I do -2 and -2, which turns out that I have the same factor repeating. So my zeros for this problem are x equals 0 with the multiplicity of 1. And then x equals 2 with a multiplicity of 2. Okay, so this is kind of a discussion of the zero product property and multiplicity, and we are going to kind of practice this in class today. I hope that made sense, and obviously I'll clear up any questions in the beginning of class. Thanks a lot, guys.